Welcome to this walkthrough of the lame machine on HackTheBox. So this machine will be the first of our attempts to complete exploitation on 10 machines without using Metasploit. I'll walk you through two exploitation routes, one of them immediately providing access at the root level, the other providing access at the user level with some privilege escalation to the root level using a manual method. So throughout this series I will be attempting to achieve root or system level access without the use of Metasploit. First we'll test connectivity to the server. And a good ping to the machine shows us that our VPN connection is working correctly. So our typical exploitation pathway is going to begin with enumeration of services using the nmap command. And I like to use TAC-SC, which runs available enumeration scripts to gather more detail about the services and their vulnerabilities. TAC-SV, which provides versioning information on those services. And we'll be scanning all TCP ports using TAC-PTAC. If we have an issue, we can come back and attempt a UDP port scan, although that is a very time-intensive process. Without the -p- or TAC-PTAC, this would only scan the top 1,000 ports, which are the most common. But for the extra minute or two that it takes to scan the remaining 65,000 ports, it really is worth enumerating all of the TCP ports. There are some exceptional circumstances where systems are set up to provide delays to responses, or that provide misleading replies on all the ports that are scanned. That can really bog down the process, and if that's occurring, then it makes more sense to switch down to a more limited or targeted port scan. But at this stage, a full port scan is preferable. Now, if you're following along, you can pause the video here, and we'll both come back in a minute or two when the results are in. All right, so there are the nmap results. So we can see quite clearly that it takes just under 3 minutes, which is a pretty good investment for 65,536 ports to scan. We can see that it's running a number of services. So it's running the VSTPD service on port 21, so FTP. It appears that it's possible to log on anonymously here, so we'll make note of that. Port 22 is open, so we're running SSH, in this case OpenSSH 4.7p1 for Debian. So likely we're looking at a Linux distribution here. On ports 139 and 445, we're running SMB, or Samba, so a Samba file share. And we also have an unusual port, 3632, which is the dist-ccd service, version 1. Script results give us some further information. That TAC-SC option gives us information about clock skew, SMB discovery. So we've got the computer name, lame, which we knew already. We have the likely operating system that it's running, 3.0.2 Debian. So we know that it's running Debian Linux. So we can see that the SMB security mode is set to guest. Challenge response is supported. And quite importantly, message signing has been disabled. And as nmap quite rightly points out, this is dangerous. So that is certainly a route that we can attempt to exploit. So overall, nmap shows us we're attacking a Debian Linux server that has FTP, SSH, SMB, and this dist-ccd service open. The script results indicate to us that SMB message signing is disabled, making it a vulnerable service. The SMB signing feature is there to digitally sign packets that are being transmitted using SMB to and from the share. And without that signing, it's impossible rather to confirm their point of origin or authenticity. So to be thorough, we can have a look at that FTP service. We can simply browse to it. And we can see that we have anonymous access to an FTP directory. Although as we browse up to higher and higher levels, they're also empty. And there doesn't appear to be any path traversal opportunities here, providing it with an expected path in a Linux system. So this is VSTPD 2.3.4, which is a potentially vulnerable service version. And we can test that with another Nmap script. So we can see all of the Nmap scripts if we have a look at the contents of the user share Nmap scripts folder. Right, so you can see quite a lot of scripts are developed for Nmap that extends its functionality beyond simple port scanning. So if we look at FTP, we can see that there is a script looking specifically at VSTP, a VSTP backdoor checker that we can run. So if we limit ourselves to port 21, to Nmap script, we'll provide it the script name, FTP, VSFTP backdoor. We provide it the IP that it's scanning, and we'll limit our search to port 21 just to, because that's the only place we expect to find any results. And in this case, it'll tell us in fairly short order whether this port is vulnerable or not. Right. And so it identifies it as an open port, but that's all. It doesn't identify it as a vulnerable service at all. The next place we could have a look, as we said, was the SMB shares. See what they look like, see if they're vulnerable to an attack. So if we're accessing SMB shares, the SMB client is our best option. And we'll start by having a look at the what's available to us. So we can use the -L to list the possible shares. In this case, we're getting an NT status connection disconnected. That's because this version of SMB client in Kali 2020 doesn't support SMB version 1 by default. And we can simply append the -- option client min protocol equals NT1, and that will fix our issue. So we're being asked for a password here. We expect we're logging on anonymously, so we can simply hit enter to provide no password at all. And we can see that we're provided with the share content. So here we've got a list of all of the shares. We've got a network printer driver share, a temp share with the comment "oh noes." That's going to be an issue for them, I'm sure. The opt share and the IPC and admin shares. So potentially there would be some value in accessing any or all of these shares. And we can do that with SMB client as well. In this case, instead of using the -L, you can use -N for no password login. And we can have a look at things like the admin share. It says status access denied. And just a note, I've had to add this escape character before the $sign because I'm running fish as my shell. If you were running it in bash, you wouldn't need to add that escape character. You just do admin $sign. This holds true for our other shares, our IPC. We get in, but once we get in, we don't have access to list the contents of the directory. So we could check them all out. In the end, what we're going to be interested in, the only one that gives us access is that temp folder. And that does provide us anonymous access, and we can list its contents. So it appears there are a few files in here which we could access. We can also see what file permissions we have within that share to see if we have read-write access to any or all of these shares. Clearly we have some read access to temp. We could also attempt to upload a file, but we also have the SMB map command. And if we use TAC-H, then we can it'll provide a list of all of our permissions. And it's working, and it says we have no write access to print, nor to opt or IPC or admin, but we do have full read and write access to the temp folder. So, searching for exploits for this version of Samba. This is 3.0.20-Debian, as we said. So Samba 3.0.20. We can see right away, top result is a Samba username map script, which is going to be a command execution vulnerability. So this exploits a command execution vulnerability in Samba, in our particular version of Samba, where we can use a sort of non-default configuration option that's been set within Samba called user map script. This is a configuration within the Samba version itself. We can specify a username when we try to log in, but instead of providing it a username, we can provide it with shell commands. And this allows us to execute arbitrary commands without authentication. And within this CVE documentation, we see that we could run a Metasploit script. There is an exploit for that, this multi-Samba user map script exploit. But we're going to try to avoid using Metasploit automation. So we'll have a look around for exploit code for this particular vulnerability. And what we will come across is things like this Samba user map exploit.py script. So this is it's written in Python 2. And that's going to have issues for us if we're running Python 3 environments. It's gone to the extra effort of byte encoding the shellcode using MSF Venom. So in this case, it is putting together a reverse netcat shell for this particular listening host on this port. That's what the shellcode looks like, byte encoded. That's not really our concern at the moment, but it does give us the beginnings of our shell exploit. So what it's really passing through is the username, and it indicates that we can send through this /equals and then a backtick, no hup, and then whatever our shell code is, because that would be the content that this was creating, and then another backtick to close it off. And we can provide it, as usual, just an empty password. So, according to the CVE, according to the exploit code example, we need to provide a meta character, so a character that acts as some other character or function. Right? That's from our information here, so shell containing meta characters. There are variations on the example code that we looked at there that are out on the internet that use a period and a slash and an equal sign, a slash and a minus sign. Some experimentation, though, reveals that for our purposes here, the slash character alone is sufficient. So then we give it the no hup or no hang up command to keep our connection alive, and we provide our shellcode, all wrapped in those backticks, which act in the same way as a single or a double quotes, but just without confusing the system about any other existing quotes that it's using. So if we begin by collecting our IP address in the VPN, in this case 10.10.14.21, and if we connect back to our SMB share using SMB client into our temp, then we can craft a logon command, which is just one of the many commands. If we run help, we can see the many commands that are in SMB. Logon is one of the standard commands that's available to us. And then we simply provide it with our meta character / our no hangup command, and then our shellcode, which in this case will be a netcat reverse shell calling back to us on port 9999. So that's what it looks like there. Log on. We've got some regular double quotes there, our / meta character, our backtick, no hup, NC for netcat, and it's going to be running on verbose, giving us a connection to, in this case, 10.10.20 port 9999, and it's going to execute a bin shell. It's going to an sh shell for us in the bin directory. Before we do that, we need to run a little listener. So netcat running as a listener as well on port 9999. So it's ready to go. We run our logon. We provide it with any empty password. And as we can see, we're connected. So now that we're connected, we can see in our shell window that we have the ability to show the contents there. And if we look at who am I, we're running as root in this, this particular exploit. So this means that we can, in this case, simply look for our predefined user text and root text files. So looking in the root directory for the name user.txt, shows us that we can find it in the home Macus user folder. And likewise for the root.txt, it lives in /root/root.txt. So we can cat those out for our flags. Which then can be submitted to the system on HackTheBox. Now that was just one way we could get in. We did find additional services running on this system. The FTP wasn't vulnerable. SSH is unlikely to be vulnerable to us without some usernames. We could do extensive username enumeration. We do know usernames now that we've been into the machine already, but from a purely black box standpoint, we didn't know that information yet. And then following username enumeration, we could attempt a brute force or a dictionary attack on the passwords. That's quite a deal of time investment for little likely return. We do want to have a look at the other item, though, that came up in our Nmap results. And that's the unusual TCP 3632 port serving dist CCD. So if we have a look online, dist CCD is a distributed C, C++ compilable server. We have version 1. And we can see that there is a vulnerability. There's a remote command execution vulnerability. Looking in here, there is a Metasploit module for it. Unix, MIS, dist, CCC, exec. But we want to avoid that for now. We can have another look at the scripts list. And we do see that there's really something for just about everything in here. It has a dist cc CVE 2004 2687 script, remote code execution, remote code injection script. We can run this script to see if it's vulnerable. And we'll run that just on port 3632. And it comes back with some results. So we can see that it is indeed vulnerable. What it also shows us is that it's returning some information about a user ID. It's running as daemon. Because we've got this positive result, we should have another closer look at the documentation for this nmap script. And we can see that there are some additional script arguments for it. In this case, the CMD, so a command to run at the remote server. So there are typically additional script arguments set. In this case, it allows us to run an arbitrary command. Basically what this vulnerability is that if this port is open and accessible, it's possible to send C or C+ code to this port, which it will compile and attempt to run. This nmap script, using the script arguments, creates some C code out of our provided command, and it sends it to this port where the compiler will compile and execute it. So we can provide it with an arbitrary command. If we were to provide it with the command ID, so nmap -p 3632, our host, our script, and the script args, --script args equals cmd equals ID, as it is in our example. You can see, again, it's giving us the ID of the user it's running as, and that's in fact what the test was running as. So it comes back as UID number 1. So it's running as the daemon for this process. We can also have a look at what sorts of permissions that user has. So instead of giving it the ID command, well, we know that we have the /home/macus user.txt file in there. We could also run find to locate that file as we did previously, but we know it's there now. And it's not sufficient to just list the file. We need to actually run cat on it. And then we get that hash back as we did previously. We could try the same command to see if we can view our root.txt file. And coming back, again, we have just an empty result. It's open, but nothing more. So it doesn't return anything. We don't have root level permissions with that daemon user to access the root.txt. We're going to need to escalate our privileges using this route. And on a Linux machine, we can use linenum to help us figure out how to do that. So linenum is a popular script for Linux enumeration, specifically for privilege escalation. Now we have a couple of options at this point to get our linenum script onto the lame machine. We could make use of our SMB temp access, but we've done that already, and it's not specific to this vulnerability. Alternatively, we can self-host a simple HTTP server and use the wget command to pull a copy onto the server. We'll test to make sure that wget is there first, using the which command. And we do, in fact, have wget on the machine, so we're good to go there. So first things first, we need to get into the correct folder. And then we run our simple server. So Python 3-m, and we're running HTTP server. We'll run it on port 80. And it's now serving up the contents of that linenum folder for anything on this network to access. We're going to need a listener before we go much farther. And finally, we can run our nmap script to get us a basic user level shell. Okay, so we've got our listener open. we'll get ourselves a basic shell. And once we're connected there, we can use wget to get the file being hosted on our local machine with that simple server. So wget http 10.10.14.21, our local host, and linenum.sh is the name of the file that we want to bring onto the machine. And we can see above that our simple server has received the GET request, and it is present on our shell. So our next step is to make that executable. And run it. Now this will take a couple of minutes just to run through all of the all manner of possible privilege escalation routes. You can pause here too while you wait for results, and we'll return when the output is returned. All right, so here is the output of linenum. Extensive, as you can see. We can go through it one section at a time to see what opportunities there are for us for privilege escalation. So at the top it gave us full kernel information, so we could look for kernel-specific exploits if that's what we're interested in doing. Where we're seeing minus signs and red, it means that there's information that's been collected, but not necessarily useful information for us to escalate our privileges on this system. We can see things like all the group memberships that are there, some admin users, the Macus user that we haven't really encountered apart from stealing the user text from their home folder. If we did want to try Macus or root for SSH, then we could attempt a brute force or dictionary password attack on SSH, because we do know that those users exist, Macus and root. We can see the contents of Etsy password. It's shadowed, so that's not especially helpful. We can do sudo without supplying a password, a possible sudo ponage with file, whatever that is. Apparently we can read root's home directory, which is something that we ought not to be able to do. But as we've seen already, we can't read the files within it, so that's not particularly helpful for us. As you can see, a great deal of information out of this, and if we know what we're looking for specifically, then we can make even greater use for it. This helps us to narrow down some of our options, though, for the many, many possible routes that exist for privilege escalation on a Linux system. So just scrolling down through all of this output, all of the services that are running. Contents of the Etsy inet configuration, binary permissions, now we get into some interesting files, file locations. So as we saw, we've got wget. We could have used curl as well. We're running nmap. We could run nmap on this machine. That's unusual. It's running its various compilers, distcc, which was the problem in the first place. And then we get into some SUID files, and in particular, some possibly interesting SUID files. So that does catch my eye. With the set user ID bit, the SUID bit, set on these, so you can see it's got this S here in the permissions, in the file permissions. Typically these would be R, W, and X if it had full permissions for that user group. In this case it's RWS, so the set UID bit has been set. If we run this program, any commands that it runs, any processes that it spawns as a result, also run as the owner of that program. And in this case, the owner is root. So if we were able to get this call DH client script to run something interesting, perhaps we could modify it or redirect something that it calls to a file that opens a shell, or we can run nmap on this system and have it do something interesting, then it would do that as root. And that's going to be our solution into this machine, because one of the interesting things about Nmap is that it has an interactive mode that allows us to run commands, and it in fact allows us to run command-line commands. So still within our shell, we can run Nmap in its interactive mode. And if we give it an exclamation mark to start the command, we can see that we're running as root in this particular machine. So we should be able to cat our root.txt file. And as you can see, we can. Right. So if we quit out of Nmap and run whoami again, we were still running as a daemon, but because we were because that set UID bit was set, we run Nmap as root. And Nmap, as we saw, lets us run in an interactive mode. We can run commands that lets us view the contents of the root.txt file. Now, just to be good guests, we will remove, well, we'll clean up after ourselves. We'll remove our linenum script. All gone. So all cleaned up and ready to go. So that's the exploitation of the lame machine by two methods. The first giving us immediate root access using a misconfiguration of the Samba share, and the second giving us user-level access, a foothold on the machine through the C compiler, and once there, running linenum to locate possible avenues of privilege escalation. We found we could upgrade to root because the set UID bit is set on the Nmap application, which has an interactive mode and allows us to run applications. And all without touching Metasploit.